Alright everyone, and welcome. Rabid here with Rabid Mining, and we're going to have a look at the TeamRedMiner update. Here's our system, 22.9, 22.6, so yeah, what should we go with there? I'd say, let's just do even 23, I suppose. Okay, yeah, so yeah, we're going to go with 23 there. We are going to be doing this test on this 5700XT Sapphire Nitro Plus. That's probably one of the best cards, or the best card you can get for the 5700 series. It's the Sapphire cards, and Nitro being the top of the line. So we are going with the 23 watts here. I'm just going to write that down. 23 watts in our system. Here's our trusty notepad with all our notes from previous videos, so we can kind of cross-reference, and we just have a little diary of what's going on through past videos so we can cross-reference. This is my system, how I'm doing this. We have our system power without any card installed. That way we know exactly what our system is using. Later on, some people were saying that, you know, the CPU draws more power and all this stuff. So essentially, when we get this test done and we find accurate numbers, I am probably just going to hook this power supply up and hook the card directly to this power supply, and we'll see if our numbers match what we match with the system and everything here. And then we can kind of get an idea, two perspectives on what's going on and how much power these cards actually draw compared to system. So here we are booted back in Hive, and just as a convenience, my test bench is not updated to the latest version. It's actually the version just before. So the latest version is the one that has all this B die and everything in there, B mode. So we are at the version before, so we'll just mine at normal settings with the previous version. We'll check out our power consumption and everything, then we'll update, and we'll see if we can actually drop this down for the same mega hash and save on power. For the record here, before we get going, we are sitting at about 41.7, 40.5. I guess we'll round it at about, we'll just go with 41. 41's a nice middle for our system idle with a card number. So it looks like we leveled out at about 55.29 mega hash. Same with this screen here. 55.3 now. 55.29. So we picked up a little bit. Might still be doing some auto tuning. But for the most part, we'll take a look at our power. 158.5.6.7. So let's go with 158, 159, 158.3. We're going with 158.3. So for our numbers here, we're sitting at 158.3 watts at 55 mega hash, well 0.32 mega hash. We got 135.3 watts when you should take off our system power, and our software is actually reading 71. If that glare wasn't there, where are we at? Right there, 71 watts. So we're actually showing a 64.3 watt difference between the software and what this card is actually pulling. Now AMD is way off on their power. A lot of us know this, but some people don't. So now you do if you were not aware of that. NVIDIA is closer, but as you see on my 3060 Ti test, that it is actually a lot closer, but it is off as well. And I also, a long time ago, if you guys caught that video, this says 5700. Now this is an XT, but I flashed my BIOS to save power, so I will put the XT version back in and we'll do this test again. And also on top of that, this is Micron memory. If you have Samsung, you can actually drop the watts on the card. Samsung memory runs like 15 to 20 watts less, so that's another thing to look out for. So you can essentially drop, this should be down another 20 watts, so like 115 watts this card will be pulling right now on Samsung memory. So we did update here, as you can see right here. Here we are, the current version, no update. Now this is the exact same settings. We're not doing what we're supposed to do yet to test the efficiency out of the new TeamRedMiner. So we're just going to look at our power consumptions. I did notice we actually getting 55.9 mega hash now, so we are up a bit on the mega hash, and our power is 158.4. So we're about the same, so 158.3. We're going to go with 158.3. All right, our numbers here. So we're sitting at 158.3, which is the same amount of power we were using before, minus 23. So we got the same power usage. We got a little bit more mega hash. That just could be due to reboot and stuff. Sometimes it's higher, sometimes it's lower with these cards. And then our software, though, it is stating 70 now instead of 71. So our software went a little lower. But we're just going to take a look now what we're actually supposed to do here. As you can see, So that you can drop the core clock now 100 megahertz and the voltage by 50 in B mode while still preserving the hash rate, although it could be a tiny loss. So like before, you'd lose like 3-4 mega hash if you dropped it like this. So we're gonna drop our core down by 100 and we'll try playing with our voltage. I notice I can only drop mine 20 and it won't post, like it'll just crash. But we'll try the 50 here, see if it crashes or not. And I'll drop our core by 100 and we'll see if we can maintain this mega hash and drop our wattage. Just before I change everything, I just want to make sure everyone can see that we are 1350 on the core, 730 on the core voltage, 820 and 1320, and 910 on the memory, which is doubled about 1820 and 1820 on if you're on Windows. So I still have this reference from when I was using that. I don't know if that's actually doing anything on the 5700s. I don't think so, but you never know. But yeah, so we're gonna drop this to 1250 and see if we can keep this 55 some mega hash here. So here we are, 55.82 mega hash, 1250 on the core, and I dropped the core core voltage down to 700 from 730. So I dropped it 30. Let's take a look at our power consumption. But yeah, we didn't lose really any mega hash at all. We're up from our very first test and we're down maybe like 0.04. But yeah, let's look at our power though. That's what matters. 155.9, 155.8. So it's bouncing from 155 to 159, but most part it's like 155.8. So I'll do the numbers on 155.8 and see what it looks like. So here are our final numbers on this test. We're still going to test out that XT BIOS, and we're going to test it on a separate power supply, so it's all by itself. So system has nothing to do with these numbers. But yeah, here we are. So we got 155 points. So we're doing 132.8 watts at 55.89 mega hash. So I subtracted from the 135 that we had up here, and there's only a 2.5 watt difference, which would save you 18 cents, 18.6 cents per month on power at 10 cents kilowatt hour. So not too much of a savings here, but it is more efficient by 2.5 watts based on these numbers. I'm going to put the XT BIOS back on this card, and we're going to take a look if this changes at all. And then we're going to put it on its own power supply completely and see if that changes numbers at all anyway between the card and the system and all this stuff, because people say, like I said, CPU draws more power, this draws more power, things draw more power. So if we just throw the card all by itself on a PSU, I think the PSU is like 5 or 6 watts. We'll even test that. And then we'll see what kind of numbers we're getting and if they match up with this or not. Okay guys, so I've been trying multiple restarts here, but I cannot get past the 55.1 mega hash mark on the XT BIOS. So the settings are exactly the same, but we are just barely getting over 55. Well, you saw in our non-XT that we were actually hitting 55.89 or something like that. 0.9 or something on that aspect. But let's look at our power anyway. What are we doing on power? 154.4. So we are using a bit less power, but we don't quite have the same amount of mega hash, 53.6. So we'll just go with a 154 flat. Okay, so looking at our numbers here, we are sitting at 131 watts on the XT BIOS here with 55.02 mega hash, which brings us to 0.42 mega hash per watt. So that is still pretty darn efficient. Now we're comparing it to here, which is our non-XT, which is 0.4208. So this update actually did make the XT BIOS seem a little more efficient than it was previously in our test. I don't know, when was it? Like a month or two ago or something. It was a while ago since I played with these cards. And then our normal settings here before the update, you can see we're at 0.4133. So we did get a little more efficient. We are using a bit less power, but it is definitely not much. Now, if you have Samsung memory, I'm not sure how it'll affect this, but it is supposed to run 15 to 20 watts less. So now I'm going to put this GPU on its own power supply. We're going to look at the numbers and see if they match up to this. That way, for people come saying about the system and stuff is drawing more power and the card's not using that much, we can actually see for sure what we're actually pulling here. Before I actually hook this up, I just want to explain how I am hooking this up. I'm sorry if this video is a little longer than usual, but it's just some information. There's a lot of new miners out there that kind of need to know. So there is no more plugs on this motherboard. Like the B250 has 3 plugs for 3 PSUs, but essentially you'll need something like this. This is a 2 PSU cable. And how it works is, as you can see here, this will plug into this PSU, and it just acts as like doing your pin trick. If you're testing your power supply out, there's 2 pins in here, you put them in, they're 2 grounds, and this will tell it to turn on. Well, this is actually running your system to your main PSU. So this will be plugged into here, this will be plugged into there. This will just send when this is turned on, it'll send a signal to this PSU to turn on. It'll just turn it on, and this will be running cards, nothing else, just the card. So I just wanted to point that out, how you kind of hook that up, and that's how you do it when you're running 2 power supplies on a motherboard with only one 24 pin. Alright, so as you can see, everything is on here. Let's see if we can run a look through here. So here is this power supply running in through just the 2 wires there. Well, this one is plugged into here, and this is where the split comes from, and that's plugged into the motherboard. So this is just, like I said, telling this power supply to turn on when you flip that switch. Now we're going to look here. We are booted up. Yes, there's no card or anything. I unplugged the PCI Express card slots. As you can see, they're just dangling down there, but not in the fan. And we're using 8 watts. So our system power supply is at 8 watts. So we're at 8 watts. So we're going to plug this in now, boot it up, and see how much power we're using while we mine. Okay guys, so here we are with the same settings and the same mega hash. Now I can push this like 58, 59 mega hash at like 1450, 1500 core. Some people do like to run it at 1450 and so, but for me and my power price, it's not worth it. It just costs too much power. So the card can hit that, but this is more efficiently, and ultimately you'll save more money in the long run paying for power, especially if you have a rig full. But let's look at our power. What are we running here? Can't really see that great, but the numbers look about right. What the heck? Okay, well, there we go. So 139.4. 139.4. All right, so 139.2. So let's take a look what that works out to be. Okay, so we had 139.4. We seen that our PSU is using 8 watts. So we came out with 131.4 once we subtracted 8 watts. And what did we have with our system? 131. So there's a 0.4 watt difference. So there's double proof that this is what your card is pulling. It's not your CPU, it's not your system, it's not drawn. It does draw more power as you add cards, yes, but only a couple watts as you add them, because I did find that out in another video. So based on all this, let me know in the comments what you guys think. But this is what that card is pulling, because it is on a power supply all by itself with a system load of its own of 8 watts, and the numbers work out to be the same thing when we based it on here when we took away the system of 23. So I hope that clears things up for some people that were telling me that it's the CPU and the system that starts drawing more power and the card wasn't using that much, and the riser and all that. But essentially this method does show you riser pull and card pull. So everything coming from that card, when you add that card, this is the power, not what the software is saying. Oh, but the software is saying 80 watts now with that XT BIOS. So it went up 10 watts there on the software side, but so that makes us what, like 50 watt difference. So yeah, never use software for the power. Here is your wall numbers. Always get a watt meter if you do not have one. And there we go. So 2 different methods of testing the power consumption with the new TeamRedMiner. It does drop it a bit, but it's not that great. If you guys have any questions, future video requests, I have tons of links, and my Discord link is in the description. Check it out. Come join us on the Discord. A lot of people to help you out if you are a new miner. If you have any questions, feel free to ask, and I'll catch you guys on the next one. Rabid out. Interesting stuff. All right, nice test.